it's a real pleasure to introduce David Policanski to you. He's a staff officer, scholar at the National Research Council for the National Academy of Sciences. Interested in natural resource management, environmental biology. And I've known David for a number of years through the NRC, but I will say that of the people I've interacted with, his knowledge of environmental science and policy and that interface runs about as wide and deep as anybody I know. He's worked on over 30 NRC committees. And these are committees like the restoration of the Everglades, recovery of salmon populations in the Pacific Northwest, the impacts, cumulative effects of gas and oil exploration in the Alaska North Slope. In other words, he's no stranger to controversy in terms of the science policy interface. He's really worked at that in some very important national environmental issues for his whole career. He's really uncanny, actually. He has this amazing ability to learn the science and to understand the policy and decision-making context for that science. And in a lot of the committee meetings I've been in, he's also kind of a group therapist of getting people to move. He moves the conversation forward in a really important way. So in addition to that, he has his own research interests. Most recently, a really interesting series of publications in the effects of catch and release fisheries, the catch and release practice on fisheries management, and also a lot of work on environmental indicators, particularly macro environmental indicators at the national scale. Biology degree from Stanford, PhD from the University of Oregon. I won't say any more except to say that it's just a real pleasure to have him here for the week. He will be meeting with people on Friday if you want a chance to meet with David. Without further ado, David, thanks for joining us to talk about decision-making, science, and policy.
I'm going to talk about this interface between science and policy because at some level, those of us who are in environmental sciences are in environmental sciences in the hope that the country and the world will be run better. And so there is this issue that we would like policymakers to take note of what we're doing. And that's the wrong button. That's the right button. And so how do we interact with these people? How do we help make happen what it is that we want to happen? So who are the policymakers? In my job, the policymakers that I interact with are mainly federal decision makers. They're members of Congress, they're members of the administration, rarely but very once in a while there'll be a federal judge. We do come across state and local officials in our job to some degree, but it's mostly the federal policymakers. And the policymakers, of course, are our elected representatives and the people that they appoint, that the president, who is elected, appoints to carry out the policies of the federal government. Who are they beholden to? That's a puzzle. Sarah Anderson on your faculty has written about this, and in theory they're beholden to their constituents. And if their constituents are noisy enough and aggressive enough and can arrange to get money in large enough quantities for them to pay attention to, then they will be beholden to their constituents. One example that I will discuss involves your senator, Senator Dianne Feinstein, who has been accused of being beholden to her wealthy friends. We'll talk just a little bit about that. How do they decide? Again, this is something that you all know, something again that Sarah Anderson has written about. There's a widespread sense that politics is somehow evil and dirty and that politicians are irrational. And I think both of those things are completely false. Politics is an essential activity that allows the resolution of conflicts between different interest groups. That's what a politician is supposed to do, and it's an essential endeavor. We can't function in a democracy without that. And politicians, in my experience, are not irrational. The things that they worry about are not always the things that I worry about, but they're not irrational. And what they worry about, number one, is getting reelected, and number two is, in fact, representing their constituents. And so if you look at a politician and figure out the person's actions in that light, I think you can understand. A story that opened my eyes years and years and years ago, we did a study on salmon in the Pacific Northwest. And the chairman of the Columbia River Intertribal Fish Commission, an American native by the name of Ted Strong, when we briefed the report, stood up and he called us a bunch of pawns of the agriculture industry, of the hydropower industry, of the aluminum industry, that we had biased and conflicted committee members, that our report was no good because we were beholden to the hydropower industry, and so on and so on. He really tore into us. And I was relatively new at my job. I guess I'd been there more than 10 years, but it felt relatively new. And I was sort of humiliated by this. And anyway, after the discussion, we finished the briefing, and we were on the floor of this great big room, and we were milling around. And Ted Strong walked up to me, and he stuck out his hand, and he said, "David, this is a great report. It's really going to advance the debate." And the light bulb went off in my head, and it was the first time at my advanced age even then that I finally dawned on me, politicians play to their constituencies. So what they say in public does not necessarily reflect their reasoned opinion or their judgments, but they need to play to their constituencies, and that's involved in how they decide. And that gets to the question as to how should they decide, and that's, I hope, one of the things that I'm going to be talking about today. So let's ask, what is the role of science in decisions? One role that we see increasingly is that it's a cudgel to beat your opponents with. And part of that is that it is a tub of molasses to delay your opponents from doing what they want to do that you use. So you dump your opponents in the molasses, and by the time they've got out, it's too late to do whatever it is that they want to do. In fact, how do they do that? They sow doubt. They say, well, the science doesn't say this, it says that. There's a whole industry on that. Another possible role of science in decisions is none. A third possible role is information for decision makers. And finally, a possible role is that it is the whole basis for decision making. Now, one of the troubles in dealing with science, in especially the second and third, well, all three roles except none, is that scientific arguments are very often, in fact, not scientific arguments at all. They are, in fact, value judgment arguments in which science is used as a surrogate. And one of the reasons for that is that science has or used to have a legitimacy. So if you get up and say, well, I don't want you to do this because you're going to ruin my view or because you're going to hurt my livelihood, that doesn't have as much legitimacy as if you get up there and say, well, I don't want you to do this because it's going to pollute the atmosphere and that'll have the following adverse consequences, and so on and so on. So people often use scientific arguments as surrogates for what are really policy arguments or value arguments. If you don't understand that, you won't often understand the basis of what seem to be scientific controversies. What should science's role in decision making be? And where you stand on this question depends on where you sit. I'm using a teleprompter now. But in my judgment, the best answer is that science has a unique role in providing objective information to decision makers. It cannot be the only factor, but as Tom Dunn, who's sitting in there, likes to argue, it's not just another voice at the table. People will some say, well, there's the agricultural interest and the oil industry interest and this interest and the religious interest and the other interest, and science is just another voice at the table. It really isn't another voice at the table. It is a unique voice. if things are being done right, because science should be an objective investigation as to how the world works. And then it should, and I'm using the word should, it should not be infused with value judgments the way the others are. Now, this is the real world, and real people are doing science, so let's not expect the impossible. But to the degree that we can, we should make sure that science tries to be an objective description of what we think is happening and separate it from the value judgments. Is that how the real world works? If I really knew that, I'd have made my fortune in the stock market, and I might not be standing here right now. But I do have some real-world experiences about science and decision-making, as many of you in this room do. And mine come primarily from working at the National Research Council, where I have worked since a little after the flood. The National Research Council was established in 1916 as the operating arm of the National Academy of Sciences. The National Academy of Sciences was established in 1863, and you might recognize, if you remember your history, that both 1863 and 1916 were periods in which this nation was at war. In 1916, it was about to be at war. And in 1863, it was established to advise the government on science and technical matters, such as ballistics and various other things. By the year 1916, it had become it's also an honorific society. Members are elected by their peers based on their scientific accomplishments and other factors. It became apparent in 1916 that there weren't enough members of the National Academy of Sciences, and they didn't have the right expertise to answer all the questions that the government needed. So the National Research Council was formed, and the National Research Council responds to requests for primarily scientific advice from primarily the federal government, but also others. It's private. We are nonprofit. We're not a governmental organization. We're not part of the government. Our website is nas.edu, and there's a lot there. And the way the National Research Council works is that we put together committees of volunteer experts, several from this institution, some in this room, thank you. The volunteers comprise balanced committees. We have a smell test. If you are asked a scientific question and you look at the committee and say, well, what did you expect that group of people to say? We failed the smell test. We, years and years and years and years ago, had a committee on the value of dairy products in the diet, and there were a bunch of egg farmers and milk people on the committee, and I think that might have been the occasion when people decided they'd better put a smell test together so that we didn't produce committees that you'd say, well, what did you expect? We have bias and conflict procedures. We produce consensus reports. We have very extensive peer review, again, several from this institution, some in this room, and I thank you again. The reports are advisory, and the NRC has a very professional cadre of permanent staff who really add to the quality of what we do. What do? Let me talk about a few examples of what we have done. One of the more controversial examples involved the Klamath Basin ecosystem in Northern California and Southern Oregon. And there are 3 species of fish that are listed as endangered. We published this report in 2002. 2 species of sucker, and the population of coho salmon that lives there was listed as threatened. And the U.S. Bureau of Reclamation, which is involved in just about every large-scale ecosystem destruction project that we have in this country, in the name of reclamation, had reclaimed the Klamath Basin ecosystem by draining the wetlands, damming rivers, doing all sorts of things, and made it a very rich agricultural area. It did a lot of, it's a wonderful part of the world. But with these endangered fishes, the operation of the Klamath Basin hydrologic system was deemed by the U.S. Fish and Wildlife Service and the National Marine Fisheries Service to be likely to jeopardize the continued existence of these fish. And what they said was there are all sorts of things that you should do. These are reasonable and prudent alternatives. All sorts of things that you should do to protect the fish. And that included keeping the level of Klamath Lake higher than it wanted to normally be, that is higher than the operations normally would be, and more water in the Klamath River for the coho. Well, 2001 was a drought year, and it should have been clear to everybody involved that if you applied what the Fish and Wildlife Service said, at the same time as you apply what the National Marine Fisheries Service said, there'd be no water for irrigation. And they did, and there was no water for irrigation. And there was a hue and a cry that was really quite spectacular. There were gunshots fired. The federal government turned off the pumps. People came out there with their guns. It was in all the newspapers. It was a really nasty, nasty series of events. So the federal government decided that they would ask the National Research Council to evaluate the biological opinions and ask whether the science that underlay the biological opinions was sound. This is sort of an example of using science as a cudgel. So they asked us this very, very narrow question about the biological opinions and was the science sound as it applied to coho salmon, short-nosed suckers, and lost river suckers. And we put together a committee. We had about 6 hours, it seemed like, but it was really about 3 months to do this evaluation. And we concluded that everything that the two agencies had done was, in fact, scientifically sound and well established, but with two exceptions. And the two exceptions were the big ones. We said we cannot find any data that support the idea that the lake needs to be higher than it has been. When you look at the data, there is nothing in the data that says you will reduce the number of fish kills, you will reduce chemical pollution, you will provide more habitat, you'll do anything that will help the fish. It's not that the data were weak, but the data weren't there at all. There was nothing in the data that said keep the lake level high. The other thing we said is there's nothing in the data that says that if you put more water in the Klamath River, the coho salmon will do better. In fact, as we looked at the data, in both cases it seemed even conceivable that if you kept the lake level higher and you kept the river level high, it might actually make things worse, but we didn't say that. We just said you can't see anything that makes it better. On the other hand, what the Bureau wants to do, which is to run the lake lower than it has been, and to run the river lower than it has been, also there's no data that say that won't be damaging. So we said there's no scientific support for the conclusion that led to having more water in the river, higher lake level. And then there was a firestorm. We released this report and we got hammered for it. And it's really interesting. When we go to Congress to brief a report, it is usually the case that the Democrats like what we do and the Republicans don't like what we did. And in this case, we went to brief the report, and the Republicans loved everything that we had done in this report, and the Democrats hated it. The Democrats said we had not had time, we'd done sloppy science. It was a fascinating, fascinating situation. In 2003, if I remember correctly, there was another low water year, and 70,000 salmon died at the bottom of the Klamath River. And we got hammered all over again. I mean, we really got hammered. And everybody said, look what you've done. And nobody noticed that the salmon that died at the bottom of the Klamath River was Chinook salmon, not coho, and that we had been very clear in our report to say This is a very narrow charge. We've been asked about coho salmon and these two sucker species. For all we know, doing this will be terrible for the other species in the river, but we weren't asked about the other species in the river. So the fact that they were Chinook salmon, which were not, the Klamath River Chinook are not protected under the Endangered Species Act, and so we didn't pay attention to them in that first report. That got overlooked. We got hammered. We're still getting hammered for this. This is 10 years later. We then issued other reports in which we took a much more holistic, broader view of the ecosystem and what should be done about it. And we said, for example, you're trying to manage the ecosystem by looking only at the Klamath River, but you're not paying any attention to the tributaries. You're not looking at the Scott, the Salmon, the Shasta River, all these rivers that in fact are important habitat for coho salmon. How can you manage the system if you're not looking at those rivers? And there were some agreements that said you can't look at those rivers. Not with us, but with others. How can you do that? You are not putting your science together in a way that allows you to make integrated conclusions and so on and so on. And that later report was fairly widely praised as being useful, but the fact that we had come in and said the science underpinning of these two decisions, we can't find it, we got hammered. We got accused of not understanding how the Endangered Species Act works, which is false. We got accused of being arrogant. We got accused of doing things too quickly. I personally had a rather spectacular faux pas at a meeting. I was asked by somebody very hostile to the National Research Council whether the Academy would knowingly publish something that it knew to be wrong. And I was completely stunned by this. I was being asked whether we are liars and crooks at the NRC, and I said, well, that's never happened. And what people heard was, we've never been wrong. And I realized an hour later what I'd said, and I tried to, I couldn't understand why everybody laughed when I said that. So I replayed the tape in my head, and I tried to correct it, but the damage had been done, and people were waving our report around in Congress saying, and the Academy is never wrong. I mean, we really got hammered over this stuff. It also was an example of what I consider scientific misconduct. We asked a particular individual who works in the Klamath Basin and is an expert on the suckers to review our report. I mentioned that we have extensive peer review. We asked this man to review our report, and he agreed to, and he did review our report. And then a little bit later, he published a paper telling the world all the scientific flaws that were in our report, none of which he had mentioned in his review of our report. Now, we depend on the goodwill of people that we have as committee members and as reviewers. If I send you the report to review and you think there's something wrong with it and you don't tell me, and then you publish a paper later on and says this report is nonsense, I don't know how to function in that environment. Fortunately, he was wrong both from not telling us and B, his science was wrong, so we managed to escape that. But that's how unpleasant this all got. I don't think I want to talk about all these here. I'll just mention very briefly wind energy. A member of Congress from West Virginia, which at the time was more famous for using coal for energy than wind, but they were putting wind turbines on mountaintops, wanted us to look at the environmental impacts of wind energy generation. I think he probably was motivated by the coal industry in West Virginia. And one of the things that I learned in this activity, I've learned all along, is that when you come to local environmental issues, it usually is not helpful to look at somebody's political label. It doesn't help you to understand whether the person is a Democrat or a Republican or an independent. This is a case where they're interested in their constituents and what they do. And Frank, in his introduction, mentioned that I have done studies on Alaska's North Slope. And a friend of mine who is a liberal Democrat couldn't understand why Democratic candidates for the Senate in Alaska were in favor of opening the Arctic National Wildlife Refuge to drilling for oil. And I explained to him that in Alaska you cannot get elected to statewide office unless you're in favor of opening the Arctic National Wildlife Refuge to drilling. It has nothing to do with partisanship. You will not get elected. If you say, I'm in favor of keeping this wilderness area, forget it, you're not going to get elected. So don't make the mistake of thinking partisan politics explains, party affiliation explains the way our elected representatives vote on many environmental issues. It doesn't. Let me talk about science in the Endangered Species Act. The wind energy study, we did a long study, and there are environmental impacts. They kill. One of the most surprising and disturbing is that wind turbines kill bats. And that was a shock both to the wind farm operators and to the scientists. I mean, this was a surprise. And they kill lots of bats, and they're put on mountain ridges in the Northeast. They don't do that here, but in the Northeast they do. That places where bats spend a lot of time, and that is a nasty environmental problem that actually hasn't fully been solved. Science in the Endangered Species Act was a wonderful example of how science should work. In 1995, the ESA had been amended in 1988. It was passed at first in 1973, and it was up for reauthorization. And we got a bipartisan letter from 3 members of Congress and said, we would like some advice on the science of this act. And they asked us questions like, are there conservation conflicts between species? What is a species? How should we decide what the level of risk is for a different species? Purely scientific questions. The letter was so thoughtful and so well worked out that we just took the letter and we just plopped it in as the statement of task for the committee. And we had a wonderful committee, and it was a very interesting activity. I talked about scientists being humans. The committee came up with the idea, one of the questions was what level of taxonomic hierarchy should be protected. The Endangered Species Act protects species, subspecies, and what it says are distinct populations of vertebrates. But it doesn't define distinct population segments of vertebrates. It doesn't define what that is. So we defined it. We said that there's something called an evolutionary unit, and that is, it is a unit of organisms that has some sort of a definable evolutionary history and future. And we said, for example, there's no scientific reason to protect evolutionary units of vertebrates and not other species, but there may be policy reasons for doing that. We talked about the fact that endangered species live both on private and on public land, and that the incentives for public land owners are different from the incentives from private landowners. So as a consequence of that, to get the same degree of protection, you might need different regulations on private land than you do on public land, just because landowners are different. Well, when we briefed Congress on this report, they didn't like that. They said, you're trying to shut down private activities. You're trying to tell the federal government it should take over private land. We said, no, we're not. We're just making a science observation for you guys. If you want the same degree of protection on private land as on public land, you probably need different kinds of regulations. And other people there said, well, you're not telling us anything. You're not giving us any policy advice. And we said, well, you didn't ask for policy advice, but we are giving you policy-relevant science advice. Anyway, we argued with them for a while. Finally, one of the guys said, well, you know, maybe I better go and read this report. But it was, in my judgment, one of the most successful examples of science advice that we have given at the National Research Council, because it did exactly what it was supposed to do. It got, I credit the members of Congress who wrote us this very thoughtful letter. We had 6 very scientific tasks, all of which were policy relevant, and we had dealt with the tasks. Now, one of the difficulties, I mentioned scientists being people, when we talked about these evolutionary units, in their beginning, the scientists on the committee wanted to include in the description of an evolutionary unit how endangered it was. And I was actually able to stop them by saying, no, what we're being asked is, what is a distinct population segment, whether it be endangered or not? The consideration of a degree of endangerment is a completely separate consideration. You can't confound them. And that sort of adherence to the science really helped that report be effective. How is it effective? One of the ways it was effective was that in 1995, the new Congress led by Speaker Newt Gingrich, and he's been talking about this a lot, had what they called the contract with America, and they wanted to redo all sorts of environmental regulations. And one of the environmental acts that was in their sights was the Endangered Species Act. It was a very nice story that is told, I believe, both by Gingrich and by Ed Wilson, both of whom were friends of the director of the Atlanta Zoo, who said, you two have got to talk. Wilson went down to Atlanta and talked to Gingrich about the importance of conservation, and after that, the Endangered Species Act disappeared from the Republican House's agenda, and there were no more attacks on the Endangered Species Act. I like to think that our report had some useful role in that. The other report I'll talk about, activity I'll talk about briefly, is the California Bay Delta. Again, we had biological opinions. The California Bay Delta, I'm sure you all know about it. It's San Francisco Bay and all the water that is the watershed to the east of San Francisco Bay, fresh water, mixed fresh and salt. There are listed species in there. The most famous one is the Delta smelt. It's about this big. Sean Hannity got famous, even more famous for doing his show there and holding up this little fish and say, they're shutting down all the water for all the farmers because of this little fish. I guess if he'd taken a green sturgeon, which can get 7 or 8 feet long, and held it up, maybe that would have made a difference, because that's another one they're holding up the water for. Anyway, we were supposed to look at the biological opinions, and again, are they scientifically sound? And I'm fairly confident that because in the Klamath report we had said, well, one of these things is not sound, the agricultural folks actually, the implication, we didn't say this, but the implication was agriculture could get more water. They thought, oh, we'll try our luck again. This is one that Senator Feinstein was very instrumental in getting her friend, Stuart Resnick, who operates Westlands, which is a water district in the East Bay, the eastern side of the Delta, was very influential. And she said, we're going to do this. I'm putting in $750,000 for an academy study. When it had first been raised, the Interior Department was not interested in doing an academy study. They didn't want to have anything to do with us. After Senator Feinstein got involved, they became interested. Senator Feinstein just happened to be on the Appropriations Committee in the Senate, just happened to be an appropriator who deals with the Interior Department. And this is an example of politics getting involved. And sorry, I'll get back to my place in just a minute here. So we did what they asked us to do, and as we had done with Klamath, we said we don't want to just look at these biological opinions, we want to take a broader look. Unlike Klamath, we didn't find anything really wrong with the biological opinions. We said that they were all, everything they wanted to do seemed scientifically justified with one exception. And that exception is that an important part of managing the system for the smelt is managing the distribution of salinity in the bay. And you can manage in the delta, and you can manage that by increasing outflow from the reservoirs and the rivers. A lot of outflow moves the salinity gradient down towards the bay. Less outflow moves it back up towards the bay. The theory was that if we had that salinity gradient in the right place, you'd have more habitat for smelt. And the committee couldn't, they said this makes sense conceptually, but we can't find any evidence that says that this actually is true. So we issued that report. It was not greeted by a firestorm of controversy the way the Klamath one was. but it had no effect. Lawsuits continued despite what we said. The judge involved, despite our report, said the biological opinions are full of sloppy science and this, that, and the other, and threw them out, or threw aspects of them out. This is the same judge who 2 years earlier had said the biological opinions aren't protective enough of the smelt, they need to be more rigorous. It got quite complicated. It got more complicated in ways that I will mention in a moment. But we then went on from that report to the larger, broader look like the one that we talked about with the Klamath. That report, in fact, should come out at the end of this month or early next month. And it'll be interesting to see whether that has any effect on the debate. There are people who think it won't. The one place where I think we might have been affected is that there is a very large program called the Bay Delta Conservation Plan, which in effect would like to get authorization under the Endangered Species Act to build the so-called peripheral canal, which has been controversial in the Bay for 60 years. The idea is if you take water from north of Sacramento and you bring it down south of the Bay, you're not going to be drawing water through the delta and causing all the damage that is currently being caused. So we'll have this peripheral canal. People are worried about it because if you put another mouth in there to take water out of another straw in, people will take more water. Nobody trusts anybody. So we had to review this plan, and the plan was just incomplete and not well thought out, and we weren't very kind to the plan. And that report was issued, and I do have some hope that the advice we provided in there as how to make the plan better will be followed. It's not clear. But the policy issues are not solved by our having opined on the science, unfortunately. People are still arguing about how much water they want and how much water they should get. And that's not a scientific question. Let me talk briefly about the Endangered Species Act. It featured in the Klamath report. It features a little bit in the Everglades report. It features widely in the Delta report. And why? I think it's because it has such sharp teeth. Unlike many environmental laws, the Endangered Species Act has a direct prohibition on harming listed species. You cannot do that. It's not a procedural act like NEPA, the National Environmental Policy Act, or so many other acts that say you have to go through this and this and this and this, and then you can do what you want. It is a direct prohibition. You cannot take a listed species. And if the federal government wants to do something that might hurt a listed species, it has to get consultation with the Fish and Wildlife Service or National Marine Fisheries Service to say that it's okay. And if it's not okay, well, you then go ahead and do that at your peril, because if you do that and they said it isn't okay, guarantee you're going to get sued and you will lose. It can stop things from happening. And one of the people that we were working with said, you know, a problem with the Endangered Species Act is it has this collateral effect, this unintended effect of stopping things from happening. And I pointed out and I said, no, that's not unintended, it's not collateral. That is what the Endangered Species Act is designed to do. That gets people really upset. People think it will affect their livelihoods, although in my judgment it doesn't. And the reason it doesn't is usually the thing they're worried about is going to go the way of the dodo anyway. The reason that the Endangered Species Act comes in there is because we're eliminating the last little bit of forest, or the last group of this, or the last group of that. They're going to have to stop doing it anyway because there isn't going to be anything left for them to be doing. And the other thing is that the Endangered Species Act is fairly flexible, so it doesn't always actually stop you from doing what you want to do. And one of the people who knows more about this than anybody I've ever met is Frank Davis, who is just wonderful at figuring out how to make the Endangered Species Act flexible and how to get where you want to go and still be protective. So let's look at some discussions of science and policy. I mentioned Sarah Anderson, who talked about the way members of Congress vote on environmental issues and how those votes are influenced. It is for something talking about how Congress people vote a remarkably sophisticated statistical analysis. But it is quite interesting. There's a paper by another one of your faculty members here. It's called How to Avoid Train Wrecks When Using Science in Environmental Problem Solving. I think the title is a little bit more optimistic than the paper. A little more ambitious is the word I'm saying than the paper, because I don't think it actually will, but it's sound advice on how to get together different forms and different groups of knowledgeable experts to work together. That's something the National Research Council has done. One of the nice things about the National Research Council, if we're talking about an Endangered Species Act issue, we don't only have conservation biologists and population geneticists and so on. We have all sorts of people of different disciplines that get together and I think often come out with a more interesting result. It's a paper I wrote in 1998 in which I talked about the situations when science advice is likely to be helpful. One of the examples I gave was the Mono Basin ecosystem study we did. The question was a policy question. Los Angeles wanted more water out of Mono Lake than there was water going into Mono Lake, and so the lake was getting lower and lower. And people who liked the lake and the things in the lake said, this is a disaster, you can't do that. And so we were asked to say, what would happen to the lake if you took this much water out? And so we wrote a report in which we said, all right, the lake is currently at this level. If you drop it 10 feet, you'll get this. If you drop it 20 feet, you'll get that. If you drop it 30 feet, you'll get that. If you raise it 10 feet, you'll get that. We basically did an ecological risk assessment and said, these are the different things you can expect at different lake levels. We didn't say don't take water out of the lake. We didn't say put a limit here. We didn't give any policy advice at all. We just said, these are the different things you can expect at different lake levels. And that turned out to be really useful to the policymakers, because they had the science information, and this was a case where they had a genuine policy problem. This is another example of how science, I think, should work, because we, as scientists, provided actual information to the policymakers that said, if you do this, this will happen. If you do that, that will happen. We didn't try to tell them what to do, because that's not our job. One of the most interesting discussions of science and policy is this paper by Ian Fain. It is called A Comment, and it's 92 pages long, and I would hate to see what a full-blown paper by him looks like. But he discusses the role of the National Research Council, and he discusses the two papers' activities. Spent a lot of time on Klamath, a lot of time on the Bay Delta, and also a study that the NRC did on the Drake's Bay oyster business up north of San Francisco that again was very, very controversial. Just very briefly, there was an inholder in this area who operated an oyster farm, and the Park Service wanted to get rid of it, and so they published a report that said this farm is hurting the seals and it's doing this damage to the ecosystem and so on. And an Academy member by the name of Corey Goodman, member of NAS, said this is no good, this amounts to fraud, they're distorting the science. He talked to Senator Feinstein, the oyster farm owner talked to Senator Feinstein. There was a big fuss. The Park Service issued a clarification 2 years later saying, yeah, we did do some things wrong, this is what's really going on. But Senator Feinstein had the NRC do a review of the report of the situation anyway, which we did. And again, I think the controversy continues to simmer. It even interfered with the appointment by Barack Obama of the director of the Park Service, Ron Jarvis. So what does Fain talk about? He talks about how the NRC works, how it applies to science and how it is used as a political cudgel. I mentioned that in the beginning. It's a very thoughtful paper, particularly so because he cites this 1998 paper that I wrote, but it really is actually a very thoughtful paper, and he has some interesting suggestions. He's got some things wrong, and he's got some things wrong for two reasons. One is that he couldn't know. I mentioned to you this reviewer that we had, who we asked to review our Klamath report. He agreed to review it, and then didn't tell us what was wrong with it and tried to publish later what was wrong with it. Fain couldn't have known that story, and so he gets that part wrong. There are other things that he gets wrong, but this, I think, is worth reading as a discussion of the role of science in making decisions. And he concludes that the NRC should not undertake studies that are really policy disputes and where the resolution of the science won't solve the policy dispute. He says the Bay Delta is one such, the Klamath is one such. Others may not be. I'm not sure you can tell in advance, and anyway we have in our charter that you have to. If the government asks you to do it and it's a reasonable scientific question, we have to do it. Lawton, president of the British Ecological Society, talked about the difficulties, again, of interfacing science and policy. And so that leads me to what we should tell Nina Fedorov. Actually, before I do that, my conclusion about interfacing with science and policy is this. We as scientists need to be as careful as we possibly can not to give policy advice when we're asked for science advice. It's damn difficult. And sometimes we can't tell the difference, but we really have to try. If somebody says, what is the science underlying this thing, so like the Mono Lake or the Endangered Species Act or even the Bay Delta, we need to say, folks, this is our best judgment as to what the science says. The implications for policy are this. That is, if you do this policy, that will happen. If you want that to happen, you might need to do this. But we're not going to tell you what to do. We're not going to tell you where to set the limits. We're not going to tell you this, that, or the other thing. So that's really important. We need to be clear where the science isn't clear. We don't know. And one of the things another one of your faculty members, Tom Dunn, is always telling us is that we need to respond to what it is that the representatives are trying to figure out. And that is very difficult. It's very difficult to know how to respond and how to phrase those things. But I remain convinced that a good, thoughtful, scientific analysis can help policy decisions in many ways. Now, let me ask, what should we tell Nina Fedorov? Nina Fedorov is the president of AAAS, and she says she's scared to death. We are sliding back into a dark area, and they are really being effective. Who are they? And they are scientific naysayers. 60% of the United States population does not believe in evolution or has no opinion. I mean, I don't know how to deal with that. And what percentage of the population does not believe in gravity or has no opinion on gravity? Acceptance of human-caused climate change is frighteningly low in the United States and is associated with political ideology. Senator Imhoff, I believe he's from Oklahoma, recently said that global warming, human-caused global warming, cannot be true because the Bible says that we will have 4 seasons: winter, spring, summer, and fall. No, I'm not going to start singing, but and he said if humans are causing global warming, then there go our seasons. And of course, global warming, no climate scientist says we won't have seasons. They're just saying that averages and means and variances will change, but we'll still have winter, spring, summer, and fall. We can't do anything about the sun angle. But that's the kind of thing that we are up against. That brings me to the role of science advocacy. I like watching Lawrence O'Donnell on MSNBC, and he said of something not related to science one time, he was talking about somebody who had done something pretty horrible. He said, you know, I have done some things in my life that I'm not proud of, but I haven't ever done anything that I am ashamed of. And you may know that many advocates, scientists who advocate, have recently been doing things that they should be ashamed of. I'm not going to mention any names. It's unfair, it's cruel, but you know who they are. They have expressed their shame, and in some cases they have destroyed their careers. So-and-so has done this. He is now ashamed of it. His career is not worth ashes. So the first advice I have, if you're going to do science advocacy, is do not ever, ever do anything that you are going to be ashamed of. You will ruin your career, and you will not only not advance your cause, you'll set it back. There was an example in Alaska where there was a debate about whether to construct a certain, I think it was a pipeline. It wasn't the Alaska pipeline, but it was something like this. And the individual involved who was opposed to the pipeline spied on people and was found out spying on people. And he set back his own cause by 10 years by doing that. So the first advice is don't do anything you're ashamed of. The second piece of advice is you need to accept that if you become a science advocate, that your scientific credibility may be compromised. It probably will be compromised, not necessarily. And that is a personal decision for everybody. Is it worth it to you? Is this so important that you are willing to compromise your scientific credibility to make this case? And the other question I would ask is whether you...
Since you said that, it's quite a powerful thing. Do you find science advocacy?
Yeah, I think that good question, Tom. Thank you. Science advocates are people like Jim Hansen at Princeton, who says global warming is such a problem that we have to do something about it. We need to curb the emission of carbon dioxide and other greenhouse gases. So by science advocacy, I'm talking about somebody who uses the science platform to advocate various policy activities.
So he's not advocating for science, he's a scientist who's advocating.
That's correct. That was unclear of me. Thank you for clarifying that. I appreciate that. So somebody like Jim Hansen, somebody like the late Steve Schneider, who did it with climate change, and various others who said, all right, I'm a scientist. The scientist leads me to this policy conclusion. And the other, okay. And finally, I will conclude by saying, I will just mention, by the way, one person who didn't do that is Sherry Rowland, who died a couple of days ago. Sherry Rowland was one of the people who discovered with Melina the effect of fluorocarbons on the atmosphere and ozone. He had a hell of a time getting accepted just for his science because of the implications of what he had done. He did it the right way, I think. Anyway, I'm scared as well, and I have no idea what to tell Dr. Fedorov about all these people who reject science. Everything I have said doesn't apply to them, and I don't know how to proceed. I hope somebody can figure it out. All the bright students and faculty here might be able to do that. And I'll stop there. If there are any questions, I'd be happy to take them. I can field them from here. Yes, there's one right in the back. Hi, Dave. It's good to see you.
I think it's really intriguing that humans are so phenomenally knowledge-dependent for our lives. And yet we're so willing to reject them. I mean, we can't live. That's what makes us unique. Our whole livelihood depends on our ability to pass on information, knowledge from one generation to another, train the next generation what we know, and then discover more. Without this, we're nothing. And yet 60% of the people reject evolution. I wonder how long
I believe it was, how long, John? I guess it depends who you're talking about. I think there was a reasonably wider acceptance within 70 years. But yeah, it was a long time. The church took a very long time. Yeah. I agree with you. I don't have an answer.
It's just intriguing.
Yeah?
That we have, I think, a major conflict in how we live and yet how economic conservative we are in accepting new information.
Yeah.
You mentioned Cambridge's contract with America, and that was also when the Congressional Office of Technology Assessment was defunded. And I'm wondering if you think that something like that is really needed, to be brought back, because the nice thing about those reports is that they really did talk about different policy options and what the scientific information of that would be, which you mentioned might be a good way to go. So if you think that there needs to be another agency to kind of navigate the policy and science like that.
To answer that question, I would like to see evidence of how it would be used, how effective it was, and whether people actually care and whether there are other agencies that can provide that information. The Congressional Research Service provides some of that information. The Government Accountability Office sometimes provides some of that information. National Research Council can sometimes fill part of that role. So it's not, the answer to that question isn't clear to me. I think it's a good question. But it's not obvious to me that there was a step change in the use of informed science in policy making when that closed. Yeah.
David, so I can understand the takeaway from your talk, as I understand it, policymakers interpret the science, and the science is obtained from data. And so my question is really about the data. Is science in a better position to have data that is created in real time? In other words, actionable information through sensors, platform, telemetry, a browser where many people can watch what's going on in real time. Is that the contemporary or more progressive way to obtain that data?
I mean, it depends what you're doing. We do have, for example, that kind of information for weather. We have that kind of information, I don't know how real time, but pretty close for various aspects of oceanography, for the position and activities of fishing vessels. We have it for air quality. We have it for a number of different things. If there are management or policy decisions that need to be made in real time, then it's very useful having that kind of information. Some of the studies that I've talked about that we did are longer term than that. They didn't require real-time information like that. So I think the ability to do that can be extremely powerful and extremely useful for managers, especially. Probably more managers than policymakers.
One or two more questions. We're running out of time. Earlier this year, I heard a talk by Ed Malbach from the Drury Basin University about public perceptions of climate change. And he raised an interesting point, which I think dovetails nicely with your science policy interface description, which was that despite these appalling statistics about overall scientific ignorance, that scientific credibility is still a very strong currency.
Yeah, interesting, isn't it? Yeah.
Scientists are among the most trusted people on the planet as a class, which, again, the takeaway I'd like to have from your talk is how do we spend that? You've given some examples of where that works, and you've pointed out that it is a finite quantity, that any one of us can squander our credibility through any number of avenues, but that nonetheless, this is a very strong currency that we have.
It is.
Proper ways to spend that in this policy interface.
My own answer to that question, it came up in the discussion we were having in the faculty lounge this morning. Where we Where we have expertise, but we don't have any extra expertise on policy. We don't have any expertise on values. We don't have any extra expertise in politics, and in some cases we may actually have less. I think we need to avoid, I don't want to criticize what other people do. My personal decision is I need to avoid going before Congress and saying we need to be more restrictive on our management of fisheries, that we need to protect larger areas of ecosystems to maintain biological diversity, that we need, all the policies I would actually like to see, that we need to curb greenhouse gas emissions, that we need to do these things. I, as a scientist, don't have any special expertise. If I start talking, wearing my science hat on those policy issues, even though they're related to the science I do have expertise in, I think I run the risk of wasting that currency, devaluing that currency. So I think that when I go before Congress and I say, these fish are less abundant than they used to be, and the evidence suggests that they have been too heavily exploited, the fishing pressure is too high, and the senator says, what should I do about it? I should not answer that question. Very hard. Very hard, but I should not answer that question and say, I should say, Senator, that's not my area of expertise. I can tell you what the tools are. I can tell you what the methods are. You have a National Marine Fisheries Service that does this kind of thing. You need to figure out, do you want to protect the fishermen? Do you want, how much money are you willing to spend? What, all these things, I can't give you the answer. And I think that is very important. There's a problem that I don't know how to solve. There are people who think very smart, I'll name names, Bill James, who some of you may know, he's a very, very smart, thoughtful scientist of baseball and baseball writer. He has changed the way we look at baseball in all sorts of important ways. He thinks that if I go and say there is in fact evidence that the global climate is warming, there's evidence that humans did it, and this is the evidence, and this is how it works, that I am being political. Now, I have discussed this with him, and I think what he says is that because I am entering an argument that has become political, even though I'm providing the science, I am being political. I haven't figured out how to resolve that problem yet, because I think as a scientist I am obliged to present that evidence. But if when I present that evidence to somebody as thoughtful and knowledgeable as Bill James is, and he thinks I'm being political, I've got a problem that I haven't solved. I'm still working on that one.
I was just curious, your talk focused mainly on the potentially conversation between decision makers and scientists. But there are other bodies out there, one of which is the public at large, and public opinion is something that scientists have sometimes a hard time influencing. And so one of my questions is, how important is this to you think?
I mean, that obviously is probably the most important, because policymakers get their marching instructions from public opinion. And so I think it's hugely important. Most of us as scientists are not very good at communicating with the public. The advice I have always given to people is explain this as if you were explaining it to your parents. Okay? And this is not a knock on the intelligence of my parents. My parents were very smart people. But they weren't scientists and they didn't have the background. If you can explain it so your parents understand it, then I think you can explain it so the public at large understands it. And that's the approach I think that you need to keep in mind. It's very difficult. The other story I had is that it's not just communication. I was telling a couple of the faculty members this morning, I had a student when I was teaching biology who came to me and said, Dr. Policanski, I don't believe in evolution. Will that affect my grade? And I said, no, not necessarily. I'm not testing beliefs. I'm testing knowledge. Your grade will be determined by your performance on the exam. He got an A. He was able to do the problems. He understood evolution. He understood population genetics, as I was teaching. He didn't believe a word of it. Had I failed as an instructor because he didn't believe as a result of my instruction? I don't think so. My job is to make sure that he knows and understands the stuff, and he did know and understand the stuff, but he didn't believe it. Okay, there are maybe 30 or 40% of the people in this country who wouldn't believe it even if they understood it. I don't know what we do about that, but I don't think it's a science problem.
Thank you, David.
Thank you.